Come on. All right, ladies and gentlemen, hello and welcome back once again to Inside Analysis, the only coast-to-coast show all about the information economy. And today, I'm very pleased to have Mike Finley on the line with me, a guy who's got very good taste in movies. We're both huge fans of Repo Man, one of the greatest movies ever made.
That's
And
right.
it's all part of a cosmic unconsciousness, sort of lattice of coincidence.
Yeah, but
And
what about our relationship?
F that. One of the other funny lines. You're like, what would you say?
Yeah,
I'm glad I tortured you.
right, right.
The lady with the metal hand, dude, it's just endless. It's the most well chiseled screenplay I've ever seen. Right?
Mm,
Like the lady with the garbage that he knocked her garbage bags over, her garbage
right.
cans. At the end of the movie, she's in the hospital complaining to the clerk. You hear
Oh,
like, it's come to something when they expect you to pick it up. It's like that's the lady that, oh my God, dude, they're brilliant.
nice.
But anyway, with that little sidetrack, Cognitive Spark. AnswerRocket has bought a company, Cognitive Spark. They build models, machine learning models, not the large language models everyone's excited about, but the old-fashioned ones that work really well, right?
That's right. That's right. The ones that are reliable, and they're such good partners for the large models. You know, the large models, stochastic, probabilistic, able to understand language, but not really able to accurately detect outliers and find seasonal patterns and perform grouping of prices and products and things. So putting small models together with the large models, it's a one-two punch.
Well, and you're seeing this already. I'll throw a bit of a curveball at you to start off. I had this epiphany a few weeks ago before doing a show. It's really quite interesting that in the history of compute, like going all the way back to the earliest days of data and files and file systems and so forth, think about the database was always the foundation. And we've spent 50 years improving its speed, its performance, concurrent users, connectors, everything around making the database faster, better, stronger, more durable. But you know what was never in question was accuracy. You would always
Mm,
get from the database what you asked from it, what you put into
right,
it. That was never
right,
even in
right.
question. It was
Yeah.
table stakes. And now all
Mhm.
of a sudden, we throw these large language models on the end of this pristine workflow, and it's like adding a noise filter at the very end, throwing the baby out with the bathwater, basically. And it's like, well, what the hell's going on there? And the
Yeah.
obvious answer is that these are incredibly powerful engines, and everybody knows that. You can just look at it and see, wow, that's a pretty cool thing that you just built there. So we want to use it, but we have to use it responsibly, and that requires a chain of applications, a workflow that leverages the database world, the deterministic world, and leverages the probabilistic world as and when necessary, like for spinning up natural language or as a co-pilot, for example. But you want the human in the loop, and you also want those smaller traditional machine learning models in there,
Sure,
right? Because
sure.
they're the ones that are precise and can do business functions well, right, Mike?
That's right. That's right. I mean, look, it's I like to say it's part of a nutritious breakfast, right? But it's not a standalone thing. Language models are part of the bigger picture. Language model based software is still software. That means it has provisioning and governance, installation and versioning. It's got unit tests. It's got all those things that make it software, SSO, right? All those things have to be wrapped around the language model. Sure, as a fundamental enabler, yes. As a technology that opens all kinds of gateways, yes, but it's still software at the end of that process. And it has to be, as you say, accurate. Now, it introduces some new kinds of requirements, like we have to be able to test semantically. I can't just say, did it say the same thing this time as last time? Because it might say increasing instead of rising. Okay,
Right.
so I've got to allow that tolerance. It's still correct, right? But what I can't allow it to say improving and increasing because not every metric that goes up is getting better, right? So we have to be careful with where we introduce those semantic tests, and at the same time, just to continue to apply all of the rigorous tests that say, look, if it's 6.1, it better be 6.1, right? It's not something like six; it's got to be 6.1. And so we have this idea of stochastic testing that has to be choosing a random subset of the results verifying those semantically, verifying them classically, rerunning that like it is, after all, machine learning based, right? LLMs are just really big machine learning models, and so they drift over time with things like changing k-shots, with changing models, with changing prompts. So we have to have drift detection like we do for ML use cases, and we have to have verification steps like we would for a traditional piece of software. So, it's really about doing more to get these things online and productive, but the payoff is enormous.
Yeah, and I think that when I look at the industry, there have been a few huge changes along the way. So one, obviously going from client server to cloud. That was a really, really big change. Now,
Mhm.
before the call, I mentioned to you my buddy David Flynn from Hammerspace, and I hear you're talking about Llama. They work with Llama. They trained Llama 2 and Llama 3. They are the data orchestration engine that's feeding the data into the GPUs. So they've done a bunch of
Mhm.
really, really interesting things there. But he made a comment on a show maybe a few weeks ago that just it blew my mind so far that I'm still trying to put the pieces back together inside here. And what he said was, if we had had this kind of hyperscale NAS architecture that we have today with Hammerspace, where what they've done is they've abstracted all the metadata management of the file system out of the storage environment into its separate layer of abstraction. So what that does is it allows for a true like parallel transfer of data. It opens up this data plane such that you can just be moving data left and right without worrying about all the sort of intricacies, the bureaucracy of the file systems and the network, et cetera.
Mhm.
And
Mhm.
what he said was, if we had had this kind of technology 20 years ago, we wouldn't have had to dumb everything down for the cloud. And I was like, wow, that
Mhm.
is interesting because it's a parallel file system. It's POSIX compliant. And we
Mhm.
joked and we bonded on our first show because I was complaining about SharePoint. I said, I never really liked SharePoint. He said, because
Right.
it's not a complete file system. Neither was HDFS. Remember HDFS taking the
Right.
world by
Right.
storm? That was
Mm.
not a complete file system. And so his point is like, if we had had that, we wouldn't have had to go down this road of having to refactor everything and focus on all these APIs, which let's face it, an API is a toll booth. That's really what it
Right.
boils down to. It's a toll booth for data. You got to stop. You got to throw your cores in. Oh, you don't have quarters.
Sure.
Well, you better get some quarters. I
Right.
remember the
Yeah.
old days. Now you can go to the HOV lane kind of thing. But I'm saying all this because it's just like, wow, you think about the refactoring that's been done. And then Kubernetes. Kubernetes comes along and throws everyone sideways. I remember talking to MapR before they got acquired, and they were telling me in like 20, I want to say 15, that they were rebuilding, refactoring their entire platform to run on Kubernetes. I'm thinking, this is a data platform. If these guys are refactoring everything, like that, Kubernetes is the future. Like it's just here
Right.
to stay, right? So we all had to refactor for that. My point now is like, I think every software company is going to have to take a hard look at itself and figure out where are we going to fit in this new model because it's a different world now. I mean, these models operate in their own environment at their own speed. It's crazy what they can do. I mean, really, it's crazy how much content they can spin out, how many cool things they can do. But there's
Right.
an impedance mismatch between how they operate and how all these traditional systems that we use
Right.
operate.
Right.
And so I
Yeah.
see you guys buying this cognitive spark
Mhm.
company as sort of part of your strategy for how you're going to navigate through this new, really dynamic world. What do you think?
Yeah, no, absolutely 100%. Look, our goal is always to be better when better models come out. In other words, I never want to do anything that binds me so tightly to any one model or any one generation of models that I can't be better when a new model comes out, right? And so, to some extent, you could a lot of companies look at some small gap in like hallucination, right? If you make a product that all it does is detect hallucination, well, okay, you're valuable for a while, but eventually the models aren't going to hallucinate because they'll start detecting under specification, and they'll start, adding their own evaluation built in parallel with the run or whatever they do techniques. And so then if all you do is detect hallucination, you're sort of out of business. On the other hand, if you're living a layer above that, if you're going another, the final mile, in our case, is what we're trying to do, is always be that final mile that gets the work of the LLM integrated with the work of the business.
Right.
If I can do that, then it doesn't matter how good the model is. There's still going to be differentiating things that have to happen because competitors are going to keep disrupting in my customer's business, and they're going to keep moving that final milepost, right? So that,
Right.
that means we have to be able to use all the tools that an enterprise has. Their experts, their human experts are going to be in the loop. They've obviously built machine learning models. We've got to bring those in. Proprietary first-party data. We have to be able to be experts at integrating proprietary first-party data with the model context. And there's never going to be a context window big enough to take all of that, right? So
Right.
we've got to be really good at taking the vernacular, the domain model, if you will, the semantic model of that business, and integrating that with the language models and grounding. I like to say grounding in and grounding out of what a language model does, right?
Hmm.
I've got to, make sure that the model understands what's being requested, and we got to make sure the world understands what the model's saying, right? So all those things are where AnswerRocket lives, in that last layer, building on top of the models. And I heard a great quote earlier this week. They talked about really working with the language models is kind of like working with Jello, right? You can't build on it. You don't just stack software on top of the model. You have to kind of probe into it and build scaffolding and structure. It's extremely valuable. You can't do without it. There's so many things that you could never code if you set out to, but you also can't just sort of stack your traditional software on top of it in layers. You have to build a scaffolding that holds that model and makes it productive. And that's exactly where we sit.
Yeah, well, and you mentioned so semantic models and
Yeah.
enterprise data, right?
Mhm.
One of my mantras right now is get your data house in order. Because
Mm.
if you're going to want to use these big, powerful models
Yeah.
and watch out for these algorithms, if you start pointing them at messy, nasty, wrong data that is all over your enterprise today, it's everywhere. I mean, no one has
Yeah.
cleaned this stuff
Yeah.
up, right? No one's
Right.
really ever been able to. It's like there were
Mhm.
no tools to do that. I mean,
Yeah.
you're starting to see a few companies come out now to try to focus on that, talking about dark data, for example. But I do think that getting your data house in order is paramount. And these model context protocols, MCP servers, where did that come from? Everyone and their grandmother now is an MCP server. I mean, like I saw
Yeah.
Atlan has
Right.
it's an MCP server. All these other
Yeah.
companies are spinning them out. But it's very interesting because the MCP, it's kind of like a multi-layered API is kind of how I look at it. And it can talk to databases, it can talk to other enterprise systems, and it can talk to the LLM. So that's why it's important, right? It's sort of the intermediary between the LLM and the enterprise data. And then the more clever thing I've seen is building a knowledge graph. Use your enterprise data to build a knowledge graph, which connects to the MCP, which connects to the LLM. Now you're really getting somewhere. What do you think?
Yeah. Yeah, yeah, no, good stuff, and all true. But I guess from my perspective, what you're really describing is ways of informing the model context,
Hmm.
generally speaking, right? At the end of the day, you're trying to get the right tokens on the input side of the model so that it says something smart on the output side, right?
Hmm.
And so you're describing an architecture, a set of layers. Okay, so use MCP to access data to get a knowledge graph. That's a way to do it. But the thing is, there's 5 new ways to do it every week, right? And none of them are wrong per se, right? They all achieve the goal. So my advice, look, 2 years ago, I'd walk into an enterprise and they would be saying, "What's an LLM? Please help," right? Today, I walk in and they've got something already. They've done something. They're usually stuck. They're usually stuck with 5 use cases that work, and every time they add number six, the one of the first 5 breaks, or they've got some new challenge that the CEO's thrown at them that they don't know how to do, or they're up and running with 200 users, but they can't scale to 20,000, right? So that's kind of the reality of it. So we don't get to tell them to prescribe, hey, you should use graph database with MCP. What we've got to do is look at where they're starting and then show them how to go forward from there. And typically what I like to do is help them with the current obstacle. Like a lot of times it's something to do with trying to use RAG too much. That happens a lot, right? Where
Right,
you assume
right,
everything is a semantic match, right? So we
right.
get through that. But by the way, the very next thing you're going to run into is, in your block diagram, you're assuming if you can do this first part right, then you do text to SQL and you'll have an answer. Well, text to SQL is an unsolved problem, folks. I mean, the Spider 2 benchmark is state of the art's about 50% out of the box, right? And
Hmm.
and if you add curated examples that very narrowly k-shot your way into the solution, you're still only going to get up to 90%. And as you said before the call, Eric, like what part of your business is good enough failing 1 out of 10 times? There's no part of your business that'll tolerate that, right? So
Right.
so what we try to walk in with the knowledge of all the tools that you're describing, the MCP protocols and the knowledge graphs and the million other capabilities that are out there. but not prescribing any of them, because we know we've got to live with some of the things that are in place. We can add some things of our own. We need to pull in third-party pieces, and we need to create new things ultimately to get these enterprise infrastructures going. At the end of the day, if they could use an off-the-shelf thing that worked every time, their competitor would too, and they'd be out of business, right? Or
Right.
they'd be commoditized. So
Right.
so for us, it's always about, showing them how to differentiate. And and you're exactly right on MCP. It is fascinating. The magic of MCP is, of course, that basically all you do is tell your model software where to look, and then it can look there and automatically discover new capabilities, right? So it's
Hmm.
this magic tool plug-in capability. It shows a little bit of amateur kind of hobby project look and feel under the covers, because that's its origins. I also see the agent to agent protocol coming out of Google as something that I feel is, it's got a lot more substance to it, right? And you
Right.
see lots of diagrams incorporating both. Again, we don't get to choose which one you use or don't use. We have to look at it and say, I'm going to make both of them work. I'm going to show you the advantages and disadvantages of each. I'm going to make a recommendation for the use case that you're in.
Right.
Uh, but I do see that as an important emerging area, that discovery aspect. And if you look at the boom that happened when the Apple Store came out, right? The App Store, where suddenly somebody working at home could come up with a piece of software and they have an automatic built-in distribution channel for it, right? MCP enables that kind of capability. I can, like I took the Google Maps API, and I built a proxy and plugged it into AnswerRocket, and did that, in 20 seconds, right? And had that up and running. And so the beauty of it is obviously there. The question is, how safe is that? How much does it cost to do it? Is that appropriate for the enterprise use case? All those things have to stack up in a line.
Right. And, from an individual client side perspective, you just said a whole heck of a lot. Like, is it safe? What is it doing? How do we
Right.
track these things? You start talking about agent to agent conversations. I mean,
Mhm.
that's one of my big questions, right? And I've been researching this quite a bit about AI agents themselves. How can they, so they're really autonomous? That's pretty interesting. How do you shut them down? How do you monitor their behavior? Boomy's building a control tower. All kinds of companies are doing things to try to become the orchestration layer for these little suckers because they
Yeah.
can do amazing things. I was on the
Yeah.
Red Panda launch last week, and those guys are blowing my mind. I was on Next Data's launch with Jamak Dagani also last week. Those guys are blowing my mind. Going all the way deep with this polycompute runtime engine thing, I'm like, well, that's pretty interesting. So it's like there are so many amazing things happening. And I can honestly say I predicted this like 6 months ago. I said, folks, we're entering an era of hyper accelerated
Right.
innovation. And
Yeah.
things are going to move at crazy breakneck speeds. And from the CIO's perspective, CTO, COO, got to be careful. But we'll be right back, folks. You're listening to Inside Analysis. All right, folks, back here on Inside Analysis with Mike Finley, excellent advisor to enterprises, and AnswerRocket's been doing cool work for a number of years. They really fuse AI into analytics, so augmented analytics, which I've found over the years has been really the best way to use that kind of technology. And I think in general, AI is going to be an advisor. It's going to be your co-pilot. It's going to be saying, "Hey, have you thought of this? Have you thought of that?" But then you start talking about agent to agent conversations. It kind of reminds me of what Kubernetes did, because Kubernetes, I mean, blew the doors off in terms of how you actually run your compute, right? Because it's federated compute, but it's stateless, right? But now I heard that the latest version of NSF supports state. I was like, oh wow, what's going on there? And really, what you always want to do in software when you build an application, you're trying to as tightly align that application with its data sources as you can and with its operating system. The better you understand the OS, the more elegantly you can design your application to use the OS. And of course, Kubernetes, it's almost like a de facto OS in a way. I mean, it's not really an operating system, but it kind of is. So it's just crazy what's happening. And I think this agent to agent stuff is probably going to be as big or bigger than Kubernetes in terms of impact and disruption and ultimately value. But what do you think?
Yeah, I know. I totally agree with you. It's funny. One of the things I've been saying lately is We used to talk about how change is the only constant, right?
Right.
I'm going to amend that. I think surprise is the only constant. In other words, when
Yes.
we are living on an exponential curve. If you
Yeah.
are not surprised, it's because you haven't read enough.
Right.
It's seriously, there is so much happening. I actually saw before my eyes, I saw an emergent phenomenon between two agents inside AnswerRocket. Agent one was designed as a chatbot to work with people to do certain analysis. Agent two was using that chatbot. It was allowed to access that chatbot as one of its tools, right? And it requested some data, and the agent one looked at it at metadata and said, no, I can't provide that. But if what you're really looking for is a way to get XYZ, then you can check this other data. Agent two said, great, give me that other data. Agent one provided it, right? They did a handshake. They literally negotiated between themselves what data to use, how to adjust the request for the purpose that the second one had, and the thing worked, right? And so it's just surprise is the only constant, and that kind of emergent. Talk about network effects, right? The network
Right.
effect of three agents that are able to speak to each other, speak meaning using natural language to achieve their goals, and where every one of them is more valuable because of all the other ones that are in that loop. And then you add protocols into it like agent to agent and MCP that allow these things to discover each other and build out. I mean, it's a phenomenal time for the enterprise. I like to say, and it'd be fun to be challenged on this. I like to say that the tokens generated by language models for the enterprise, the tokens generated by language models are worth about 1,000 times what they cost. I think it's
Hmm.
about a 1,000x on the value of it.
Wow.
And I can say that based on, look, if I give a couple of 100,000 tokens to a model, that's roughly like a paperback book you might read at the beach, right? It's
Hmm.
roughly a couple of 100,000 tokens. And I want to take that, and let's say I want to distill it down to something actionable. It's maybe 1,000 tokens of output, like that a human would actually be able to look at. And then there's 9,000 more tokens that show me how it decided that and what the references are and everything, right? So that kind of a
Right.
task, you're talking about a $2 task and for a language model at
Hmm.
most. With our best and most powerful language models, it would cost you a couple of $1,000s to get a human to read that entire book, provide you a synthesized version of an answer that's well thought out with all the reasoning behind it, right? And that's just one use case. Now, you get narrower if you say, okay, now a 100-page manual and you have to answer questions over a phone line, right? That's another use case with it, obviously, where Sierra lives these days, where it's just a huge multiple. I think it's about 1,000 to 1, and that's why it's compelling for enterprises to take advantage of this technology, right? It's just you can't not do it.
Yeah, to your point earlier, you have to be careful about how you use it. But to your point, there are so many use cases, as we call them in enterprise computing, where these things do such a fantastic job that you're crazy to not use it to do that job. Now
Right.
you have to figure out which job that is. Like it's for summarization, for example, as you suggested, taking a huge pile of text. Even, and here's the thing, these AI agents can call on LLMs. They can
Mm.
try, I want you to connect to this system. It's like, okay, used to have
Yeah.
to hire a data engineer and he'd spend maybe 2, 4, 6 hours, maybe a couple days. Oh, it's giving me error messages. It's timing out this and that. Well, the AI agent just checks, oh, that didn't work. Let's go to the LLM. Oh, it says use this, try that.
Right.
That didn't work. Let's do this. Let's try that. And boom, now I'm in. There you go. You're done.
Yep.
It's like, what?
Exactly. Yeah.
I mean, what it's it's mind blowing. Basically,
Mm.
what the guys from Red Panda were doing earlier this week was really really impressive. They spun up these demos where you're just watching this stuff happen. It's just like, oh my god,
Yeah.
that's what when you figure out how to use it. And it's the cool thing is it's a lot of the real nitty gritty. Tedious stuff that no one
Mhm.
wants to do anyway. Like, who wants to do actual systems
Right.
integration?
Right.
Basically,
Right.
no one. People do it
Right.
to make money, right?
Yeah, and honestly, the resources to do it are scarce and expensive. So frankly, there's just a lot of it that doesn't get done, right? It's sort of like in the healthcare system in the US anyway, right? There's almost like by attrition, I'm just not going to bother because there's such friction to go get a doctor to see you. So if I'm not better in 3 days, right? But if that doctor were really easily available, you would go today, right? And I think
Right.
it's exactly the same thing here. I think there's so many, there's so many cases when I deal with in the packaged goods space, as an example, they'll use people to look at their big brands in big geographies, but they just neglect small brands in small geographies because they don't have the resources to get there. Not even if they wanted to spend the money, they just literally don't have the people that are trained on how to do what needs to be done. If I can take the abilities of that big brand, big geography person and apply them to small brands and small geographies, informed by the magic of X or reviews on other social media sites and the latest supply chain data. And by the way, here's the weather. I mean, it just opens up possibilities that you couldn't address previously. And the enterprise is recognizing that superpower and embracing it.
Yeah, it is a superpower. That's a good way to put it. It's super powerful. I heard a quote yesterday on a Boomi call because Boomi World is coming up in a couple weeks, and they said that right now 80% of Boomi employees are using some agentic workflow for their
Mhm.
job, and I was like,
Yeah,
well, that's
yeah,
impressive. Like,
yeah,
because
yeah,
you have to play around with this stuff to understand how it works and to understand what you can use it for. But I mean, for research, it's tremendously powerful.
yeah,
And on
yeah,
anything that has been widely published about, it'll be pretty darn good. But I remind people, it is a consensus engine. It will show you the average of whatever it is that you're looking for.
yeah,
And
yeah,
so for fringe topics, it's not going to be so good. It hallucinates more around very esoteric
yeah,
topics. But
yeah,
there are other issues too, because it's like, you think about the media, and how could a media company realistically contend with the power of these LLMs as long as they're fed with transactional data of what's really happening, like on the stock market or something?
yeah,
You could
yeah.
just spin up stories all day long that are based upon the data spinning right out of the stock market. Now they need data, they need fact sets
Mhm.
around which to weave their story,
That's right.
and
That's right.
that's the key, right?
Yeah. Well, and and as you pointed out, it's important to actually ask the model not to use facts from its own training. Most of my customers don't care what the model saw in the annual report of their competitor 2 years ago. They want to see the latest results from that competitor that are published in syndication, right?
Right.
So we spend some energy in our product and with our customers getting the model to use its semantic capabilities to understand the meaning of words and the meaning of sentences and the nuances and so forth, but not to use what it thinks it's our knowledge of facts, right?
Mm.
Because when the model tries to recall facts, you're exposed to hallucination, right? When the model tries to do math, you're really exposed to hallucination. So we try to guide the models and layer the process so that we're never referencing the pre-training that the model has, only accessing facts that have been pulled into the context for the purpose of the current question.
So how do you do that?
Yeah, yeah, yeah. So how do you do that, right? So yeah, so there's it's funny we have a series of these 8 pitfalls that I see over and over and over again. And this is one of them. Hallucination is one of them. So is, choosing the right model. So many people make mistakes choosing models. So is choosing the use cases, applying structured data, all sorts of pitfalls. But let's talk hallucination specifically for a second. So a model hallucinates because it's trained to make you happy. So let me explain what that means. The reason a language model is an autoencoder. An autoencoder means that the answer is built into the question. And that's the auto part, meaning I don't have to say, hey, these 100 pictures are apples, right? These 100 pictures are cows. Instead, I just show it all those pictures and I ask it to decide what's a group of things and what's another group of things. And
Hmm.
then I say, oh, those things that you put in that bucket, those are cows, except for that one really rotten apple. You got that one wrong. It's not a cow, right? Or these things in that group, we're going to call those apples, right? And so the autoencoder is trained on the internet by filling in the next word. That's the famous, completing what you just said. The label
Hmm.
is whatever the next word was. So the label essentially is in the picture, if you will, right?
How interesting.
Yeah.
That's cool. That's
Yeah, yeah.
interesting.
And,
So
and
where
so,
does that deploys, like, so in your software when you deploy somewhere, like
mhm.
where is that in the chain basically? Is that something that you've kind of baked into the your interface or your UI or something, or how does it
Yeah.
actually get baked
Yeah,
in?
yeah, no, it's a great question. So we as a service provider, because we do have software, but it doesn't always get deployed. A lot of times we're just advising. So this is really a technique that is built into our software, but it's also built into our practice, right? When we're helping customers, and essentially there's a couple of steps to it. First of all, if you ask a model to answer a question, it's going to try like hell to answer it because nowhere on the internet in any of its training did it never not have an answer,
Hmm.
right? There was always the next word that it could predict for you, right? So it's going to hallucinate an answer if it doesn't know one. So the very first thing to ask a model is, can you answer? Right? So by asking a model in the flow of getting you an LLM result, if you ask it, hey, is it possible to know who is president of the United States based on this list of sales data? The model's going to say, no, that's not possible to know that. So now I know that it doesn't know the answer to the question, so it won't
Hmm.
hallucinate who the president is. If I didn't
Wow.
ask it that way, it would hallucinate who the president was when its training was finished, which is obviously going to be incorrect, right? So
Hmm.
we layer these steps in the process of showing how to build the software in a way that doesn't hallucinate.
Yeah, that's very impressive. That's really quite impressive. And then, so you mentioned RAG models and like overuse of RAG models, for
Yeah,
example. I
yeah,
again, I'm partial to the graph RAG model
yeah,
because you
yeah.
create a graph and that
Mhm.
represents the relationships within your organization of entities
Right.
to customers, to products, to
Mhm.
service items, to Jira tickets, or whatever the case may
Right.
be. That gives you some nice, rich what do they call it? They like connective tissue, basically.
Sure,
So
sure.
you're really grounding the model, right? So you can
Mhm.
get the best information from it. And I think to myself, I came up with this idea. Let's see what you think, and then we got a break coming up in about 2.5 minutes. But I came up with this idea. I call it the executive cockpit. And the idea is that small language models will be very powerful, and you can have one in your own data center. You carve out part of your data center for your small language model, and then you train it on all of your data, all your clean corporate data, enterprise resource planning, CRM data,
Mhm.
customer lists, transactions, even support tickets, all that stuff. Then you
Mhm.
set up topics, either Kafka or Red Panda or something, from these enterprise systems into the small language model, such that the
Mhm.
executive can sit there and ask questions all day long, like how are we in sales in the Northeast region? Well, if I had
Mhm.
to lay someone off, who would I have to lay off? The point
Mhm.
being, through that architecture, an executive should be able to see basically anywhere and get ideas on anything that's happening in the company. And that
Yeah.
becomes sort of a beating heart of, or a beating brain, if you will, of the enterprise. But what do you think about that?
Yeah, you're describing the digital twin, right? The idea that we had
Right.
from way back
That's
when
right.
of saying,
Right.
and we tried to capture the digital twin with databases, but we missed the cognitive part, right? We missed the idea of the engine that could understand the data, that could have those
Right.
interactions with you. I do
Right.
think that's where it's going. I don't think it'll be a small model that's trained though. I think
Hmm.
it'll be a trillion plus parameter reasoning model with
Hmm.
really deep
Hmm.
tools to do access, to run forecasts and find the outliers and look up competitors and search online, right? To make all of that come to life.
That's crazy. I mean, really, it's just,
It's coming.
I think that we still don't know the costs of these things. I mean, there are so many sunk costs, and obviously, what we're looking at right now is this massive land grab by OpenAI, ChatGPT, Gemini is pretty far behind. Anthropic is doing pretty well, and they're trying, but they're investing so much money in building these things. Then DeepSeek comes along and distills their models and can do the same stuff. It's like, what the hell's
Yeah.
going on there? So
Right.
it's like the other shoes just keep on dropping, and that's what you were
Yeah.
saying earlier, right? Is that surprise is the only constant. It's like
Mhm.
DeepSeek surprised the hell out of just about everyone on this side of the ocean. Everyone was like, "Oh
Yep.
my God, what are we going to do now?" We did a show on it. Actually, we did a. I had this idea 10 years ago. We finally did it a couple months ago of a called a rapid response webinar, where something happens in the market. I'll get you a webinar with 200 registrants by tomorrow at noon. And we did that,
Nice.
and it was
Yeah.
awesome, dude. It was a
Very
deep
cool.
dive. But folks, don't touch it down. We'll be right back. You're listening to Inside Analysis. All right, folks, back here on Inside Analysis with Mike Finley of AnswerRocket. We're talking all about large language models, reasoning models, and there's this talk about benchmarks of and with Llama 4. And I've known all about benchmarks for years. They can be very useful for understanding which technology performs better in this scenario or that scenario. I look at these large language models and I think it's got to be really hard to come up with any sort of meaningful benchmark that will give you an accurate comparison between the models because they're so big and they're so unwieldy and there's just so many directions they can go. It's like how do you quantize that? Is I guess my question, but what do you think?
Yeah. Yeah, no. So you're exactly right. I mean, it's the original, foundation of AI. Well, the Alan Turing's Turing test, right, was well, if it quacks like a duck, it must be intelligent, right? If it can fool you into thinking it's human, then it's intelligent, and if it's not a human, then it's artificial. Therefore, that's what AI is, and in fact, that's what this LM arena is really all about, right? Is sort of scoring in an ELO style tournament, scoring models against each other to see, which one is smarter, which one's better, and I respect these benchmarks and all the benchmarks that are on the model cards because somebody spent time thinking through what those tests are, and it's a way of putting a yardstick up to the models. But frankly, in my use cases, the commercial use cases, when a model is carrying a workload and delivering ROI, the only benchmark that matters is how it does in the enterprise.
Right. That's right.
Yeah,
That's right.
and
It,
so
it's
so so really the way that the model is chosen to begin with has a couple of layers to it, right? Not starting with the model cards, right? But it has to start with do you trust that this model is not going to result in a lawsuit because it was trained on something that it wasn't allowed to be trained on, right?
right.
So there's a series of criteria that allow you to sort of discard models, right? Do I know how it was trained or not? Do I trust it, right? Is it fast enough for the application that I want, right? Is it going to generate tokens at a pace that is going to keep up with what I want? Does it stream, right? Or is it going to produce the results in a way that I can't get to them as they happen, right? So you can pre-qualify models and get down to a set that sort of meet your criteria. The same way that there's 100 databases, but you don't issue 100 RFPs when you're going to put in an enterprise database. You reach out to the vendors that are at the scale that you need that are within the stack that you have, right? And so that gets, once you've qualified those models, then you kind of get into the next tier, which is, okay, what is the cost? What is the reliability? How big is the context window? What is the latency, base latency versus peak latency, right? So now I'm really choosing a model, not so much in saying how well does it answer questions pretending to be a human.
Hmm.
Understandably, that is a way of evaluating models, but not at the enterprise level. In fact, for me, that baseline test for the enterprise model is really just the set of examples that you've captured, the K shots that you've captured that are ensuring the model is going to do a good job at runtime. You can literally use your K shots as a way of evaluating a new model and sort of hitting two birds with one stone.
Yeah, it's very interesting. I'm going to make an analogy here and see what you think because I think it's quite fascinating. So, data warehousing, I talked about, the history of data and getting faster and more performant, all that fun stuff. Teradata, of course, was the 800-pound gorilla in that industry for 30 years,
Right.
probably. They're
Mhm.
still around. They're still doing business. They're still, cranking away, doing that kind of stuff. But who came along? Well, first there was a bit of a sidetrack with Hadoop. We thought this file system could change the world, and I think I was on record saying I don't know if MapReduce is going to solve all the world's problems,
Weren't
but
sold, yeah,
yeah, we'll see what happens there. But of
right.
course, it did. We learned amazing things. So it did
The
some
logo
cool
was
stuff.
cute.
What's that?
The logo was cute.
Yeah, the logo, the cute little elephant. Yeah, exactly. Elephants never forget, too, right?
That's
Don't
right.
forget
That's
that.
right.
But then, so what happens? Snowflake comes along, and one of the very clever things they did is they realized, this whole schema change thing is a real pain in the butt. And it's like, because back in the day, you had to know which questions you're going to ask. All these things had to go before you actually went and built this skyscraper. Well, one thing that they did, I thought it was very clever. Well, first, of course, separate compute and storage. But two, they focused on being able to tear it down and spin it right back up with a new schema. And I'm like, that's clever because now you can adapt to the needs of the business. Now, the graph people would argue, hey, a graph also can move all around. So you can build in your flexibility in that graph
Right.
layer. You got to have flexibility
Sure.
somewhere. But I'm thinking to myself, what might happen here is these, of course, these big models are amazing, but you can do distilled models like DeepSeek. And I'm thinking that purpose-built industry models are really going to be the best. And I will bet you that we're going to come to a point where we can kind of spin up our own models, a fairly small one, and maybe like you say, is it a reasoning model? I don't know, but I think that we'll see the same pattern evolve in the AI models as we saw in the data warehousing models, which is like, let's break it down into component parts, be able to spin them up quickly and get them
Mhm.
performant and get them running. And then
Right.
if it doesn't work, pull it down and spin up another one. But what do you think about that?
Yeah, no, I think you're definitely right. In other words, today we're living in this world where, we're accessing these proprietary models in the cloud, or we're deploying some open models in our data centers, but they're very monolithic. They're very sort of like, yep, take it or leave it, or spend a bunch of money distilling it or quantizing it or whatever. But it's sort of it's not very loose, right? It's hard
Hmm.
to spin up a new instance. You better pay for a lot for your peak demand if you always want low latency. I think a lot of those friction points are going to go away. I think you're right in that regard. And to some extent, it's because the aspect of the models that understand language, that have common sense, that can apply a thoughtful process of going from step A to step Z. Those things are becoming commoditized, right?
Right.
Those abilities aren't that special anymore. I mean, it's I can't believe I'm even saying those words, but it's true. Like a thing that is as smart as a high school kid is not that hard anymore, and there are a lot of different models that do it. So now it's a matter of saying, where can I put it? How fast can I spin it up? How quick can it answer? How cheap can it be? Right. So I'm gonna solve a lot of problems that I would solve, for those kinds of cognitive loads. And I'm going to look for much more engineering focused ways of putting them to work, as opposed to being so focused on what does the model card say and how much are the tokens, and the kinds of things that we ask ourselves today. I
Right.
think it is an evolving set of constraints. And the same way that you wouldn't think of a database the same way 30 years ago as you do now. I think the timeline is much shorter. I think in 3 years you won't think of a language model the same way that we do now. I think you may not even care what the model is behind. What you're looking for is the application of it, and how well it performs for your business.
Right. And I mean, that is the end of the day. What we're always looking for is
Right.
something that will do the job better. But when I sit down and think about the 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 mountains of legacy architecture that exist out there, think Salesforce, think SAP, think
Yeah.
even Marketo. Like these are old tools now, man. Marketo is a
Yeah.
very old technology. I'm sure they've got new stuff, but it's like
Right.
even like Salesforce has its own little data, as I recall, its own little data foundation, basically that
Oh,
they
it's
came
not
up with.
little. It's
Well, it's
not
not
little.
little, but yeah, in other words, it's their way of doing
Yeah,
things, which
that's
was
right.
come they came up with 30 odd years ago. So it's like, huh, if you have a reasoning engine, where I'm going with this real quick, and we got our final
Mhm.
break coming up in a second, 2 minutes here, is, we could see the cream rise to the top. And you have these, especially with agentic AI, these agentic systems that can reach in and grab things as needed to do what has to get done. And a lot of the heavy lifting of the old days is probably going to go away, I
Right,
think,
right, right.
which is
Yeah,
good. That's
no,
what you want, right?
yeah, yeah. If you need, if you need a piece of code that converts X to Y, the model can just write it on the fly.
Right.
We we've
Right.
got we've got cases where databases that would have had to be joined through some sort of a mapping table. We just load the information into the context, and the model puts it all together and makes the output, right? And then we fact check it to make sure that it did that
Right.
correctly, right? Because you have to. Same way you would if you ask a human to do the work. And we apply the right layers to make sure that the correct model is being used for that kind of task. But man, it's a huge step forward in terms of what you can get done and when. I do think models are part of solving the problem of all that legacy software. I
Right.
think they're sort of the wrapper around it that lets us go forward.
I think so too. I think it's going to be really fun the next few years. And, frankly, I think companies in the business intelligence space, like yourself, the analytics space, they're the ones that you're on the cutting edge, but you're also on the bleeding edge. Like if you don't move quickly enough, I think that functionality is going to be absorbed somewhere else. I mean, look, I'll just give you an example. We'll pick this up after the break. Stack Overflow, which people have gone to for years now to learn how to do this, how to do that. Their traffic dropped by like 50% not that
Mhm.
long ago. I mean, just
Yeah,
off a cliff,
yeah,
basically. And if you're a media company, that's your money. Like that's what allows you to sell advertising and to impress companies to get them to give you money. That's what you need
yeah.
to have, and it's gone. Like it's just because they're
Right.
using Copilot. And it's like that is a straw in the wind, my friends, when all of a sudden I don't have to go here anymore. These
Yeah.
engines are just scraping it. Now, the downside is that if you're not populating that information anymore, what are the engines going to scrape? Right. So it's
Right.
like there
Yeah.
is a certain point at which, wait a minute, if we don't feed it enough real stuff, then it is going to start to eat its own tail and just go completely bonkers. But folks, will be right back for the podcast bonus. You're listening to Inside Analysis. All right, folks, you're back here on Inside Analysis podcast bonus with Mike Finley from AnswerRocket. They've just bought Cognitive Science. That's what it's called, right?
Spark.
I'm
Cognitive.
sorry, Cognitive Spark. Yeah, which
Right.
they build machine learning models. I think the ML models and the AI models, that is the new sizzle. It's the new sex. It's the new cool way of doing
Right.
things.
Right.
But you can't lose your bearings. Like, don't throw the baby out with the bathwater. You know, got to keep the ship running, but use
Mhm.
these things. And you kind of hinted at something that I've also believed as well, which is I think these models are going to be great for optimizing the legacy architectures, for
Mhm.
optimizing what you do. Think about like in the earliest days of DM radio, I was wrapping my head around all this ELT, ETL stuff. And this is, we're talking 17 years ago. But I
Sure.
thought to myself, we got to stop the madness. I mean, I don't know what
Hmm.
is going on out there because you were moving so much data around so often and you're only
Yeah.
using 10% of what you moved. So that you really have to
Right.
move it all. And if you could just do it on demand, then you don't have to do all that crap. And that to me is another really interesting side of these models, especially through an MCP. If you could start talking to all your enterprise data, like
Right.
you're going to get the answers in language format right away. Why is the system
Yeah.
down? This node failed, and then that happened, and then this happened. It's like, oh my
Right.
God,
Right.
the troubleshooting, which has
Hmm.
always been a nightmare. I don't care what anyone says. No one likes to debug someone else's software.
Right.
First
Right.
of
Right.
all,
Right.
no one likes to do that kind of troubleshooting because it's like being a car mechanic. You could spend all day and all night and not find the damn problem. But I think these engines are going to find those problems and help us fix the infrastructure. What do you think?
Oh, I agree with you. And but the thing is, they're going to do it because they're more like people, not because they're more like computers. And let me
Interesting.
explain. I think that all these different data sources. If we said, all right, the task is to join them all up, and then once that task is done, we'll come up with the algorithms to run against all that data, and then once that's done, we'll figure out how to forget about that. You're in a waterfall. It's gonna your competitors are going to be twice as big as you
Right.
before you get done. Now, on
Right.
the other hand, if you say, all right. I know there's a data source over there. And what I need to know is, what happened on Tuesday because there was a big outage, right? Then the first thing a language model is going to do is write code that decides
Right.
what it needs to pull from that data. And then it's going to pull the data and then it's going to write code that looks at the data and decides what happened, right? There's a very simple experiment that I do with people, which is to just dump telemetry data into a language model.
Yeah. I
Car
love doing
one,
those.
it's for a car race. Car one was at 0 at time 0. Car five was at position 10 at time 8, right? Whatever, like literally a play by play of what's happening in a car race, right? Where each car is at any given time. And then you say something really easy. How many times did car five pass car six or something like that? Language models are terrible at that. Why? Because they're trained on language. They're not trained on spreadsheets. They're not
Right.
trained on streams of telemetry data. So, but instead, if you say, hey, write a Python script that looks at this data and tells me how many times car five passed car six, it'll nail it every time, right? And it's a
Wow.
beautiful thing. And it'll say, oh, by the way, did you know that car six passed car five? And that happened 3 times. And it looks like turn four is where, right? So this is, I think, bringing together these capabilities, the codex models that know how to code, the text to SQL models that understand how to pass the Spider 2 benchmark and get through the SQL processing, the narrative models that know how to take something that's really big and turn it into something that a human can absorb quickly, putting those
Right.
things together in an agentic way. Now you're talking about essentially augmenting what your entire workforce can do, not what one person can do.
That's right. And see, what I see coming down the pike here will be agentic systems that one optimize the legacy architecture because let me tell you, it needs to be optimized. I mean, bottom line, that's what I found so impressive by Hammerspace is that after and their one of their top guys was joking with me the other day. He goes, just imagine going to a bunch of venture capitalists and saying, okay, my plan is I'm going to spend 5 years clearing out the cobwebs in Linux to help the whole world be better, be a better place while we're building our engine to leverage the improvements that we're making in there. And that's our
Right,
plan. And you'd be laughed out
right.
of the room. Luckily, he made a lot of money in his last company and he funded it himself. And I'm like, oh, like
Mhm.
when I first met these guys, I was like, you are the first company I've come across, and I've been in this business 20 years. First company, 25 actually. I'm getting old. First company come across that took learning from HPC and brought it into enterprise data. And it's like,
Hmm.
why did that never happen? I mean, I was at a HPC show in Austin in like 2009 or 10, and I'm looking all around, and there's no Cloudera, and there's no Hortonworks, and there's not even any SAP. There's like none of those guys, but it's this
Hmm.
huge conference, and it's the
Yeah.
universities, it's life sciences, it's all that stuff. They have high performance computing. That's why it's called HPC. I'm like, why don't you guys talk to each other? And, I
Right.
think the answer is because they're centers of gravity and it's a cultural thing. But it's crazy that you should absolutely be pulling from this environment into that environment. That's why you have
All these
research
techniques. Hmm.
consortiums, right?
Yeah.
So they did that. I was like, that is impressive. When you take
Mhm.
years to build out and to the community, they went all the way in. I joke that you can't shift any further left than into the kernel of the operating system, right?
Right.
I mean,
No
that's
doubt.
like
No
shift
doubt.
left. We're going
Yeah.
all the
Yeah.
way
Yeah.
down.
I mean, look, you and I both remember when you could use the keyword register in the C programming language. You could tell the compiler, hey, I'm going to use this variable a lot. Give it a piece of hardware, right? Give it like you could reach into the metal right back then. And
Wow.
so many of those techniques are sort of lost now, right? We're way up at this kind of very lofty level where, one little instruction is gonna literally take trillions of cycles on the CPU or on the GPU to run, and you just have very little awareness of that. And all those techniques that were used back in the day on mainframes and other HPC environments, those are all gonna serve us well now in terms of optimizations to the pipelines that make the language models not just faster, but also less energy consumptive, right? They're gonna
Yeah.
they're gonna make it greener technology to use.
Right, right. And but you made a good point, and I think this is where, some of the reasoning will come into play. It's like a sniffer. Like there are these there's a company that does, what do they call it? It's both analytical and transactional, OLTP, OLAP, and it'll determine. It's got a sniffer up front that says, okay, this query coming in, is this a transactional query? Is this more an analytical query? And then it'll route it
Right.
accordingly. And
Hmm.
that's
Hmm.
what you're going to have. You're going to have more, and I guess maybe the MCP could come into play there to a
Yeah.
certain extent too, right? Build some
Yep.
intelligence to do. Okay, this is a simple request. Just give it the answer. This is.
Right.
I mean, you can tell that Google's doing that already. When you Google
Yeah.
something, it's thinking, okay, is this old fashioned or new
Right.
fashioned? And
Yeah.
what a difference an era makes. I mean, oh my God. Like I use ChatGPT all the time now to ask
Yeah.
complex questions and I get whole
Right.
beautiful answers. They're getting real good too about current stuff. So
Hmm.
it's like
I
Google
was,
is in
yeah.
trouble.
Well, in trouble, or they have a challenge, right? They've got some resources. But I was working with a customer the other day. They have two working solutions, each of them able to answer, a subset of the questions. And they said, look, the goal is to smash these together and make one solution. And I just said, look, you have two things that work. You're gonna make one thing that's broken if you do that, right? Why don't you put an orchestrator on the front of that just routes
Hmm.
the traffic, and
Right.
and then by the way, sometimes it's going to be A, sometimes it's going to B, sometimes it's going to be both, and then put it back together at the end. And by the way, if you need to bring in C and D and F, you'll be able to do that now, because what you built a layered solution that's able to take, to accomplish those things, right? And I think that's just a key. In fact, you and I sitting here talking, we have 6 layers in our brain because that's how biology made us, right? We have the
Right.
primitive brain, and then the one that came after that, and then the one that came after that, right, all the way up to the cortex, the neocortex, which is like a napkin wrapped around the wrapped around your head, right? The Jeff Hawkins from the Redwood Institute likes to talk about that. The latest layer that mammals have wrapped around the brain,
Right.
it's just
Ah.
it's just the next level up, and it's got these tendrils that reach down and tell you, hey, I know the building's burning, but your kid's in there, right? So the
Right.
primitive says, no, no, don't run in. The cortex says, that's the next generation, get in there, right?
That's right.
And that's what's going to happen with these systems. The ones that work
I
are going to
love
get
it.
wrapped by newer technology that uses that working layer.
I love it. Look this gentleman up online, folks. Mike Finley, Answer Rocket. What a wonderful show. You've been listening to Inside Analysis.